Most of what I've talked about until now has been fMRI data analysis. And if you recall, MRI data comes to us off the scanner in the form of volumes. I once compared these to Rubik's cubes, and all the smaller cubes inside of that cube are called voxels. Each voxel contains a single number representing the intensity of that voxel. For T1 weighted or structural images, this determines the boundary between white matter and gray matter from cerebrospinal fluid. In T2 weighted images, it represents more active voxels compared to less active voxels. This is fine for most fMRI analyses. However, voxels have certain issues. For one, a single voxel can encompass information from two anatomically distinct areas. For example, if a single voxel encompasses two distinct gyri, this can make localization of fMRI activation much less accurate. Another problem is that with voxels and volumetric data, it's much harder to estimate structural properties, such as gray matter thickness and gray matter volume. To address these problems, we're going to use FreeSurfer, a program that reconstructs the cortical surface from a three-dimensional volume. The reconstruction process converts the volume from 3D voxels to 2D triangles. The points of the triangles are called vertices, and the lines connecting them are called edges. Each vertex contains numbers indicating gray matter volume and thickness, as well as other surface measurements. These surfaces can then be inflated. This allows you to better visualize where fMRI activations and gray matter differences are located along the gyri and sulci of the brain. In FreeSurfer terms, the cortex is parcellated according to atlas boundaries, and the white matter and subcortical structures are segmented into distinct regions. We'll use these terms later when discussing FreeSurfer output files. For each of these parcellations and segmentations, different numbers are calculated, such as thickness and volume. You can export these to tab-delimited text files and then analyze them. In the next video, we'll be going over how to install FreeSurfer on your machine and review the output of the FreeSurfer directory structure. I'll see you soon. This is a quick overview of how to download and install FreeSurfer. All you need to do is go to this link and follow the instructions step by step. I'm going to show you how to use it on my machine. I have a few quirks that are specific to my operating system, but if you feel confident enough, just go ahead and do it on your own. You'll save yourself some time. If you're still with me, here are the system requirements. Now, just for reference, I'm using a MacBook Pro from 2011, and it works fine. So if you have that or more recent, you should be okay. Next, here are the build platforms. I'm going to focus on the Mac OS build platform. If you click and download this DMG file, it unpacks and installs like any other DMG file. I'm not going to go over the specifics here because that's pretty straightforward. Now, click on this link right here, because for Macintosh users, you'll need to install Xquartz 2.6.7. The rest of this page has a useful visual guide on how to install FreeSurfer onto Macintosh, but I'm not going to cover that here. Now, with setup and configuration, it has two separate shells it goes into. So remember, Macintosh, the terminal is like a Unix emulator, and different shells have different syntax for the commands. Now, for a Macintosh, I use the T shell, and I know that upsets a lot of people who just love the bash shell, but tough bananas, I use the T shell. To make this easier, click on the Apple Systems and Preferences, and then Users and Groups. Look away while I type in my password. And then right-click on your username. Click on Advanced Options, and then switch the default, which is bash, to TCSH. Wasn't so bad, right? Once you've done that, open up a terminal, and then add these two lines to your .cshrc file, which is your startup file for any new terminal that opens up. You can do this through VI Editor, or just open it up with a normal text editor. And here are the two lines of code that I add to mine. You could ignore everything else, but these are the most important ones, corresponding to these lines right here. And once you've done that, anytime you open up a new terminal, you should see this output right here, showing that all of these variables have been set, and FreeSurfer will need to set them in order to run appropriately. There are two environmental variables you should be aware of. One is called FreeSurfer Home. This is in all caps. If we look at that variable, it's an applications FreeSurfer, which is the default for the Macintosh download. Now within that, we have several different directories, which we'll get into at a later time. And you also have a environmental variable called subjects_dir. And this is where you process any of your subjects. So if you don't want to use the subjects folder in FreeSurfer, because let's say you have different studies and you want to use them at different times, here is the easiest thing that I've found. So in the T shell, set env is for setting an environmental variable, and I set subjects dir, and then in backticks pwd. So if I look at that again, that should return the directory where I set the subjects dir variable. So it saves you some time. Now, once you've done that, follow this link to obtain a license key. Give them all of your personal information, if you think that's a wise idea, and then they'll send you an email with a license.txt file. Click on Download, and you can either show this in Finder and manually move it to your FreeSurfer home directory, which in my case is applications/FreeSurfer, or what you could do is from that Downloads folder, move the license.txt file to FreeSurfer home. And once you've done that, you can test out some different commands to see whether FreeSurfer is set up appropriately. So let's try this command right here. MRI convert sample 001. I'm going to go to FreeSurfer home and then to the subjects directory. And we are going to type MRI convert sample 001, and let's convert it to temp.nifty. It works, didn't throw an error, so that means that FreeSurfer is now configured and ready to run. You can follow the rest of these commands and see whether it does in fact work. And in particular, check to make sure that FreeView is working okay. Again, make sure to install that Xquartz 2.7.6 file before you try to use that. We'll cover these other commands, such as recon all, and examining the directory structure in future tutorials. FreeSurfer is a very complex program, which can take several hours to process a single subject, and several days, perhaps weeks, to analyze an entire data set. At the same time, many of the commands are very simple to use. This video will review the command recon all, which does all of the FreeSurfer preprocessing. Recon all stands for reconstruction, as in reconstructing a cortical surface. All it requires is a T1 weighted anatomical image with good contrast between the white matter and the gray matter. Recon all first removes the skull from the volume and creates the file brainmask.mgz. The volume is then segmented into cortex, white matter, and subcortical structures, which is stored in the file aseg.mgz. Recon all makes a first pass or original guess about where the boundary is between the tissues. This is called the orig surface. It then makes a second, more refined guess about the white matter boundary. This is called the white surface. Once this boundary is established, recon all expands outward to the outer boundary of the gray matter. This is called the peel surface. The distance from the white surface to the peel surface is the gray matter thickness. These surfaces are then inflated like a balloon. These inflated images, one per hemisphere, are stored in the file called inflated. These images can be inflated even further into a sphere. The sphere is then registered to a template sphere in FreeSurfer's template directory FS average, an average of 40 subjects. This surface-based registration allows for more accurate alignment between the major gyral and sulcal landmarks. The cortical parcellations of the template are then mapped back onto the individual subject and adjusted for small variations in the individual's anatomy. These parcellations are taken from two atlases that come with FreeSurfer, the Desikan-Kiliani Atlas and the Destriou Atlas. Statistics can then be calculated from the atlas parcellations. Now let's look at the command recon all. Navigate to the directory containing your anatomical images. In this example, I have 6 anatomical images, 1 per subject, and let's say that this represents an entire dataset. If you want to run a single subject through FreeSurfer's recon all, type recon all-s and then the name of your subject. You'll want to use some kind of numbering system to keep your output organized. In this case, I'm going to call it subject 01, and -i will specify the anatomical input for recon all. In this case, subject1_anat.nii. The -all flag means to do all of the pre-processing steps. Recon all has about 30 different processing steps. If you notice that FreeSurfer has failed at any stage of the pre-processing, you can go back and run a subset of those steps to save time. We'll cover these in a future tutorial on failure modes. If you have any permission to write errors when using recon all, then type the following: sudo chmod -R $8+W $subjects_dir. Recon all shouldn't have any permission errors after that. If you go ahead and press enter, you should start to see output like this. All of this is being written out into a subdirectory in your subjects.dir folder. Let's see what that looks like. Note that subjects.dir is specified as the subjects directory in the FreeSurfer directory. We can change this later if we want to. To navigate there, type cd $, all caps, subjects_dir. Notice that we have a new directory, subject 01, which we specified in the command line, and that it's now being populated with subdirectories as recon all runs. This will take about 6 to 24 hours, and then you can see the full output. You may want to save your output to a directory other than subjects.dir. Let's say we wanted to save the output to the current directory. In that case, I could type the following: set env subjects.dir and in backticks pwd. If I type echo subjects.dir, that's now the current directory. Then, if I run recon all, the files will be located there. Note that this is T-shell syntax. You can replace the pwd and the backticks with an absolute path to the directory that you want. I prefer to add another option to recon all called qcache. This smooths the data at several different kernels, which is useful for group analyses. We'll cover that and more in the next tutorial, when we prepare our data for group level analysis.